Hello everyone. Let's take the solutions but one by one of your physics segment. The first question here says, a body of mass 1 kilogram is thrown upwards with a velocity 20 meter per second. It momentarily comes to rest after attaining a height of 18 meter. How much energy is lost due to air friction? So, here we can use a ball is thrown up. Okay. So, two forces are acting on the ball, air friction and gravitational force, and it has some initial velocity and finally it is at rest. So, there is some change in kinetic energy. So, to calculate work done by air friction, we will use work energy theorem, which says that work done by all the forces is equal to change in kinetic energy. Since two forces are acting, the gravitational force downwards and the air friction which is also downwards. So, work done by the gravitational force plus work done by the air friction is equal to change in kinetic energy. Now, work done by gravitational force is minus mgh and work done by air friction, this is equal to change in kinetic energy. Finally, ball is at rest. So, whatever is the initial kinetic energy will be the change in kinetic energy. So, it is half mv square, where v is the initial velocity. Then work done by air friction is equal to half mv square, and this comes plus mgh. Take m common, so it becomes v square by 2 plus gh. Or now put the values. M is 1 kilogram, initial velocity 20 meter per second. So, 20 into 20 upon 2 plus g, let us take g 10, and h is 18 meter. So, this is equal to, now this becomes 200 plus 180. Plus we have made some mistake. There is some minus sign. Oh, sorry. We should write final kinetic energy minus initial kinetic energy. Finally, the kinetic energy is 0. So, it should be minus half mv square. Okay. You can see final kinetic energy minus initial kinetic energy minus half mv square. So, this should be minus. Now, 200 minus 200 plus 180 is minus 20 joules. So, work done by air friction is minus 20 joule. Of course, it is minus because air friction is opposing the motion. Next question. Next question here is, stopping distance of a moving vehicle is directly proportional to. Now, stopping distance means a body or an object is moving and finally it stops. So, how much distance it covers before stopping? So, we can use third equation, which is v square is equal to u square, and here it is retarding motion because the body finally stops. So, minus 2 as. Final velocity is 0. So, s is equal to u square upon 2a. Now, if it is a uniform motion, that means acceleration is constant. So, s is directly proportional to square of the initial velocity. So, option 1. Next question. A body moves a distance of 10 meter along a straight line under the action of a force of 5 Newton. If work done is 25 joules, the angle which the force makes with the direction of motion of the body. So, you know, work done is equal to Fs cos theta, work done is equal to 25 joules, force is 5 Newton and displacement is 10 meter into cos theta. Now, this is 5 and this is 2. So, cos theta is half. So, cos theta half means theta is equal to 60 degree. So, 60, the force is acting at an angle 60 degree with the displacement. So, option C. Next question. A body of mass 5 kilogram is placed at the origin and can move only along x-axis. A force of 10 Newton is acting on it in a direction making an angle of 60 degree with x-axis. So, a body can move only along x axis. So, force in whatever direction force is acting, it will move only along x axis, the displacement will be only along x axis. So, a 10 Newton force is acting on it in a direction making an angle of 60 degree with x axis and displaces it by 4 meters, the work done by the force. Okay. So, a body is moving along x axis, displacement along x axis is 4 meter, a force is acting at an angle 60 degree with x axis. So, the component of force along displacement is F cos 60. Then force into displacement is work done. Now, force is 10 Newton and cos 60 is 1 by 2 and displacement is 4. So, this is equal to 20 joule. So, option D, last option. Next question, a particle moves under the effect of a force F is equal to Cx. From x is equal to 0 to x is equal to x1, the work done in the process. Now, here you can see force is equal to some constant times x. Force depends on displacement. So, it is a variable force. When work done by variable force is integration f dx, or the general definition of work done integration f dx, and displacement occurs from 0 to x1. Now, put the value of f force, which is Cx here, Cx dx from 0 to x1. Now, C is a constant, it will be taken out, x integration x is x square by 2, from 0 to x1 it will become C x1 square by 2. So, work done by such a force is equal to half C x1 square, the second option. Next question, the potential energy of a certain spring when stretched through a distance s is 10 joule. So, there is a spring, and if it is stretched by a distance s, the work done is equal to 10 joule. The amount of work in joule that must be done on this spring to stretch it through an additional distance s will be. So, it has to be further stretched by an additional distance s. Initially, the stretch or the displacement was s, and finally, the total displacement becomes s and additional s, that is 2s. And since the spring force is a conservative force, so we can write that work done is equal to the change in potential energy, the change in elastic potential energy of the spring. So, and potential energy of the spring is equal to half kx square if the displacement is x. Now, final potential energy minus initial potential energy, which is change. Finally, the displacement is 2s. So, this is half k 2s square minus initial displacement is s. So, half kx square. Now, this becomes 4s square, take it out. So, 4 times half ks square minus 1 time half ks square. So, it is 3 times half ks square, and half ks square is equal to 10 joule. It is given in the question, then when it is displaced by a distance x, the work done is 10. So, for this you will write 10. So, it becomes 10 into 3 into 10, which is 30 joule. So, work done in stretching the spring by an additional distance s is 30 joule. Next question, a spring 40 millimeter long is stretched by the application of a force if 10 Newton force required to stretch the spring through 1 millimeter. So, you know, for a spring the magnitude of force is equal to kx, then k is equal to f by x. Here it is given that force required for stretching 1 millimeter is 10. So, 10 Newton upon 1 millimeter, which is 10 raised to the power minus 3 meter. So, it becomes totally 10 raised to the power 4 Newton. So, the spring constant is 10 raised to the power 4 Newton per meter. Then work done in stretching the spring through 40 millimeter. Now, if you have to stretch the spring by 40 millimeter distance, what should be the work done? Okay, so we can calculate work done. The magnitude of the work done or the value of work done is half kx square. Here k is equal to 10 s to the power 4 and x, the displacement required is 40 millimeter. Now, 40 millimeter will be 40 to 10 s to the power minus 3 meter and squared. Now, this becomes 10 s to the power minus 2 with this 0, and 10 s to the power minus 2 squared is 10 s to the power minus 4. Minus 4 and plus 4 is just 1, and then here it is 4 squared 16, 16 by 2 is 8. So, the work done in stretching the spring by 40 millimeter is 8 joule. Next question. At any point, if you think the things are going a bit fast, you can pause the video, of course, and note down everything. Okay, next question. A position dependent force F is equal to 7 minus 2x plus 3x square Newton acts on a small body of mass 2 kilogram and displaces it from x is equal to 0 to x is equal to 5. The work done in joules. Here again force is position dependent. So, work done will be equal to integration f dx, where x is from 0 to 5. Then integrate 7 minus 2x plus 3x square dx from 0 to 5. 7 dx. So, integration is 7x, and from 0 to 5 it is 7 into 5 minus 2x, integration is x square by 2. So, 2 will be cancelled from here, then just x square, from 0 to 5 it is 25, 5 square. Now, here it will be 3x square, after integration it becomes x cube by 3, the 3 will be cancelled, and x cube from 0 to 5 will be 125. So, plus 125. Now, 125 minus 25, 100, and this is 35. So, 135 joule will be the work done. Next question. Two bodies of masses m1 and m2 have equal kinetic energies. If p1 and p2 are their respective momentum, then ratio p1 is to p2 will be equal to. Now, you know kinetic energy is equal to half mv square, and now here divide and multiply and divide by m. So, it becomes m square v square upon 2 times m. This is momentum square. So, p square over 2m, or P is equal to under root 2mk. Okay. So, two bodies now the question have equal kinetic energies. If the two bodies have equal kinetic energies, then P1 upon P2 will be equal to under root m1 upon m2, under root m1 upon m2. So, this third option, C option. Next question from the same formula. A light and a heavy body have equal momenta. Which one has greater kinetic energy? Now, so from here you can see k is p square over 2m. If momentum is same for both the bodies, then you can write that kinetic energy is inversely proportional to mass. So, lighter body will have greater kinetic energy and heavier body will have lower kinetic energy. So, for this question, the lighter body will have more kinetic energy. Next question. A ball is projected vertically upwards with a certain initial speed. Another ball, so a ball is projected upwards, straight line with certain speed. Another ball of same mass is projected at an angle 60 degree with the vertical with the same initial speed. At highest point of their journey, the ratio of their potential energies. So, you know potential energy in case of gravitational force, potential energy at a height h is mgh. So, potential energy, let us say this is body 1 and the body which has been projected at an angle 60 degree, say this is body 2. So, u1 upon u2, since mass of both the bodies are same and g is same for both the bodies, so it will be just h1 upon h2, the ratio of height attained. In this case, the height attained in vertical upward motion, okay. So, in vertical upward motion, the height attained from third equation is equal to u square by 2g, and in projectile motion, this motion, the height attained, say this is h2, the height attained is equal to u square sine square theta over 2g. Then the ratio h1 upon h2, so u square upon 2g, u square upon 2g will be cancelled. Here it is 1, here it is sine square theta. So, it will be 1 upon sine square theta, and theta is equal to 60 degree in this case. So, 1 upon sine square 60, and sine 60 is root 3 by 2. So, 1 upon root 3 by 2 square, this is equal to 4 by 3. So, the answer is 4 is 2, 3. Next question. A body of mass 4m is lying in xy plane at rest. So, in xy plane at origin, there is a body of mass 4m. It suddenly explodes into 3 pieces. 2 pieces each of mass small m move perpendicular to each other with equal speeds v. The total kinetic energy generated due to explosion is. So, total mass is 4m and it explodes into 3 parts. 2 parts, 2 pieces each of mass m move perpendicular. So, let us say one piece is moving along x axis, one piece of mass m is moving along x axis with speed v, the other piece is moving along y axis, other piece of mass m moving along y axis with the same speed v. Then the third piece will move in some this direction from the conservation of momentum, because the resultant of these 2 momenta will be along this direction, this direction. So, the momentum of the third piece should be directly opposite to the resultant of these 2, so that finally it can be 0 again. Now, so the mass of third piece is 2m, and we can calculate the speed of the third piece. The resultant of these 2 momenta, mv and mv perpendicular, the resultant will be mv root 2. Now, momentum in this direction should also be equal to this value. Now, say this velocity is v dash, so 2mv dash is equal to mv root 2. So, v dash, from here you can see v dash is equal to v upon root 2. So, now you have got speed of each part, then total kinetic energy will be simply the sum of each kinetic energy. Here it is mv square, here it is also mv square. So, mv square plus mv square plus half, and here mass is 2m, half 2m, and speed is v by root 2. So, v square by 2, v square by 2, and you can see 2 and 2 gets cancelled. So, half mv square here, and here also half mv square. So, this is equal to 3 by 2 mv square. Okay, so the option D. Next question. Next question. A bullet of mass 0.02 kilogram is traveling horizontally with velocity 250 meter per second. It strikes a block of wood of mass 0.23 kilogram. So, there is a block of wood of mass 0.23 kilogram and a bullet of mass 0.02 kilogram traveling at a speed 250 meter per second strikes the block, and block is resting, which rests on a rough horizontal surface. After the impact, the block and bullet move together and come to rest after traveling a distance of 40 meter. The coefficient of sliding friction of the rough surface. So, the block is on a rough surface, bullet hits the block, and after the strike they move together and finally or eventually they come to rest at some point. So, and this distance is equal to 40 meter. So, you have to find the coefficient of friction between the block and the surface. Now, we can calculate the initial velocity of the bullet and block system from conservation of momentum 0.02 into 250 momentum of the bullet, and initially block is at rest. So, that is this value, and finally, both are moving with same speed, both are moving together. So, mass will be 0.23 plus 0.02, which is 0.25 into, say, common speed is v. Then v is equal to, from calculation you can see this is from calculation v comes out to be 20 meter per second. So, initial velocity of bullet and block system is 20 meter per second. Finally, they stop. Total distance they cover is 40 meter. So, from third equation we can write v square is equal to u square minus 2as. Final velocity is 0. Initially it is 20. So, square 400 minus 2. Now, in case of frictional force, only frictional force, the deceleration will be mu g, because the frictional force is mu mg and divided by mass will be acceleration. So, deceleration is mu g. So, mu g and s is 40, then mu is equal to 400 divided by 2 into g, which is 10 and 40. Okay. So, this is equal to 0.5. Coefficient of friction between the block and the rough surface is 0.5. Next question. Two bodies A and B have masses 20 kilogram and 5 kilogram respectively. Each one is acted upon by a force of 4 kilogram weight, that is 4 g, g is gravitational acceleration. If they acquire the same kinetic energy in time t a and t b, then the ratio t a t b will be. So, two blocks, block A and block B, masses are 20 kilogram and 5 kilogram. Each one is acted upon by a force of 40 g, that means 40 Newton. So, each one is acted upon by a force of 40 Newton. If they acquire the same kinetic energy, so after traveling for some time T A, it has kinetic energy K, and for the block B, after traveling some time B, it has kinetic energy K, and these two are equal. Then you have to find the ratio T A upon T B. Okay. So, we can calculate, initially they are at rest, so we can calculate the final velocity. Now, final velocity from first equation for V A, for the block A, final velocity will be acceleration into time, and you can see acceleration here is force upon mass, acceleration is 2 and time is T A. So, 2 into T A, and for B the velocity will be acceleration into time. In this case the acceleration is 40 by 5, 8, and time is T B. So, 8 T B, and kinetic energy with these velocities will be, kinetic energy of A is half, A mass of A is 20 and V square. So, square of this will be 4 T A square, and kinetic energy of B will be equal to half, mass is 5 and speed is 8. So, squared is 64 T B square. Then take the ratio. I mean now these two are equal. So, if you equate them, half gets cancelled. So, you are left with 20 into 4, which is 80 T A square is equal to 5 into 64, 5 into 64 T B square. Now, this is 16 and this is 4. So, T A square upon TB square is 4, or TA upon TB is equal to 2:1. Okay. Take the square root. So, the ratio of required times is 2:1, the option second. We can take one more question. A spring gun of a spring gun of spring constant 90 Newton per centimeter. So, the spring constant K here is the spring constant K is 90 Newton per centimeter. So, it will become 90 into 10 raised to the power 2, or 99 into 10 raised to the power 3 Newton per meter. Is compressed 12 centimeter by a ball of mass 16 gram. So, the displacement in the spring is 12 centimeter, or 12 into 10 raised to the power minus 2 meter by a ball of mass 6 gram. If the trigger is pulled, the velocity of the ball is. So, there is a spring and it has been compressed by a ball, it has mass 16 gram. Now, the velocity initially, when the spring comes to its natural length, the potential energy will be transferred to the kinetic energy of the ball. So, kinetic energy, initial kinetic energy of the ball will be equal to the stored potential energy of the spring when the displacement was 12 centimeter. So, half mv square should be equal to half kx square, and you have to find velocity. So, v square is equal to kx square upon m, or if you take square root, so it becomes x times k upon m. The displacement is 12 into 10 raised to the power minus 2, and k is 9 into 10 raised to the power 3, and mass is 16 gram. So, 16 into 10 raised to the power minus 3. Now, this goes up and becomes plus 3. So, total it is 6, and if you take out from the square root, it becomes 10 raised to the power 3, and this gets out as 3 and this as 4. So, 3 by 4. So, total becomes 4 times 3 is 12, and 10 raised to the power minus 2 and plus 3 is plus 1. So, 10 here, and 3 into 3 9. So, total it is 90 meter per second. So, initial velocity of the ball will be 90 meter per second. So, this was it. We will meet again in the next segment. Thank you.